Hello, good morning. Welcome to chemistry class. Today we are going to be talking about the topic titled matter. Before I go ahead, I would like to tell you to sit in a conducive environment so that you can be attentive and be along with me every step of the way. And don't forget, you have to have your notebook and your pen with you. I still remain Oyelami Jane Etetune. So over to the solution to previous assessments. The first question under the assessment I gave you, I said, the reason why I took a time to do this is that many a times when you do your assessment, you won't know maybe you are on the wrong side or on the right side because the assessment doesn't mark the theory part. So it only gives you the answer or your score for the multiple choice, of which I can tell you that most of you are doing very, very well. So for us to be on the same page with the answer to all my questions that I've been giving you, I did this, so I want you to follow me closely. So question 1 says, there are 2 categories of sources of water. Explain 2 examples under each of them. The answer here is that there are 2 categories, which are what? Natural and treated water, as I gave you in the notes. So under natural water, the example you can find there, you find rainwater, you have well water, you have spring water, you have lake water, sea water, ocean water, and all of it. So I just decided to take the first 2, which is rainwater and well water, to explain. So rainwater, this is the purest source of water, as I told you earlier on, and it is formed by condensation of water vapor in the atmosphere. Don't forget that. That's what comes down as rainfall. So then the second one, which is well water, the explanation goes thus: it contains a lot of clay, okay, mineral salts, and bacteria. It can only be as a source of drinking. You can only use it as source of drinking if you follow these 2 conditions, if you follow it closely. The first thing is that the inside of that well must be lined with bricks. That means you must concrete the inside. And at the same time, after lining it, not just lining, you must cover it. You must look for a cover, maybe iron material that you use in covering it. Then the second one is that you must cite it. It must be cited, okay? It must be cited from underground water pollution. When you say underground water pollution, that means anything that can link to the water, such as pit, latrine, sewages, and all that. So you must make sure your well water is well cited, that is away from this kind of pollution. Then the second one in that question 1 says, example of treated water. So I gave you like 3 or 4 here. So the one I'm going to talk about is distilled water. Distilled water is same thing as chemical pure water. When you made a pure water with chemical, okay, it's chemical pure water. Then it is used in laboratories. They use it in laboratories for diluting reagents or for analytical work. Analytical, when they want to know the amount of substance or elements in a particular procedure or in a particular test. You have to use water free of iron and everything. So they usually use distilled water in the lab for that. Okay, those are the 2 things they use distilled water for. Then the next one, which is chlorinated water, is used in swimming pools. Any swimming pool you find yourself going to, chlorinated water are usually used, okay, for swimming. Is a source of treatment for the water. Anyway, for you to be safe. Okay, question 2. In the removal of hardness in water using slake lime, what could be your precautionary measures or suggestions, okay, so as to achieve desired result? And what's the desired result? The desired result should be you have a water free of hardness, right? And why do you think your suggestion is to be and there too? Okay, the first thing on my answer is that slake lime. Slake lime, as we all know, slake lime is a calcium hydroxide, which is CaOH into 2, which I wrote here. Okay, there's it, and is used to remove temporary hardness of water. Don't forget that. Okay, but the precautionary measure or suggestion to achieving desired results, which is water free of hardness, is to use a correct, I use it in capital letter, you must use correct amounts if you want to achieve the desired results. If this is not added to, what do you have? It will lead to permanent hardness. Don't forget that. It will lead to permanent hardness of water. You can check that from what I gave you in the notes, and the chemical equation is likewise there. So the question 3 says, advantages and disadvantages of hard water, that you should give me all the advantages and disadvantages of hard water. And I'm now telling you in your notes, I gave you in a whole slide, okay? I gave you the advantages and disadvantages. I even gave you up to either 6 or 7. So make sure you check them out. Then question 4, explain hardness of water and removal of permanent hardness. We all know that hardness of water is when you talk about hard water, you are talking about water that does not readily form lather with soap. Okay, there is water that doesn't readily form lather or foam with soap. So how can you remove permanent hardness? You can remove it in 4 ways. The first one, which I told you, is not always being used, which is distillation process or method, because it doesn't involve chemical. They prefer using chemical for removal of permanent hardness. Okay, and the second one, which is addition of what's it called? Baking soda, which is disodium triisocarbonate 4. That one will remove the permanent hardness. Likewise, the addition of caustic soda, which is your sodium hydroxide. And the final one is ion exchange resin, which is same thing as a permutate method. Okay, please try to check them out in your note. They are all there. Okay, so the class D, answer to the class D is that hard water is uneconomical because it causes wastage of soap. Okay, when the water doesn't form lather with soap, that means you have to put more and more and more of soap, so it causes wastage of soap. Okay, it does not readily form lather with soap, consequently large amounts of soap is required. Okay, I guess that's taken. So correction to elements and compound, which was the second one. So I told you to explain centrifugation and crystallization as well as chromatography. You can find them all here. So centrifugation in a nutshell is when you have suspension. The suspension is solid, but it's not as solid as the one you have in filtration. You know, in filtration, you can easily filter because they are big, solid, suspended in water. But in this case, it's made of small particles that is dispersed throughout the liquid. So you have to remove this suspension. And how can you do that? Because they are all over the water, you have to use a process called centrifugation. And in this process, the whole solution is being spun round. When you spin something, okay, you spun it round very fast in a centrifuge. There's an apparatus called centrifuge in the laboratory. So when you do that, the solid gets flung to the bottom of the test tube. So you can now decount it decantation is when you easily remove the water from the solution, leaving the solid behind. Okay, you carefully remove the water. That's decantation. Then the next one, which is chromatography. This one is all about separation of color. For instance, you have a sample of black ink that has like 3 colors in there. The thing you have to do is that you put this black ink on a chromatography paper and dip this paper into suitable solvents. Okay, I'll show you that diagram very soon. You dip it inside that solvent, and at every point in time, each of these colors in the black ink, they separate out based on their solubility in the solvent and the way they are absorbed based on their different solubility and their absorption on the chromatography paper. So the last one, which is crystallization, is a process where wort salt is being obtained from seawater in a vast scale. When they want to get salt in a very large amount, it's used worldwide. Okay, this is done by using heat of sun. They heat the solution, which is seawater, and a lot of water are being evaporated, leaving what? Saturated solution. When you say something is saturated, that means it has more of solutes that it can dissolve at that particular temperature. So it makes the solution thicker, and the solid will not be able to dissolve. So with time, that saturated solution is as well called brine. Okay, it's called brine. So this is the process of crystallization. Then before I explain the one of mixture, which is, I want you to see the diagram here. For the chromatography, this is the black dots on the chromatography paper. Dip into a solvent in the beaker right here, and you see them separating out based on their degree of solubility and absorption in the paper. You see 3 colors being created there. So that's the way it's being done. Then the question 2, mixture can be classified in several ways. Explain. There are all the features of mixture are in the notes given to you. You can see them right there. How you can know a mixture when impurity mixed with what important thing that you need to separate them out. Okay, this is the answer to the class drill, and you can see the differences between mixture and compound from page 18 of your IGCSE textbook. You can as well see it in New School Chemistry and as well as Essential Chemistry. So this is the solution to chemical equation I gave you in the class. So just look through, is well understandable. Okay, today we are going to talk about the topic named matter, and under matter we are going to be looking at meaning of matter. We are going to look at the 3 states of matter that we have. Okay, we are going to look at the kinetic theory of matter. Kinetic theory of matter. Then we are going to look at the changes that accompanies matter. Okay, the first thing, we all know that from GS1 or primary school, that matter is anything that has what? Mass and occupies space. Anything that has mass and occupies space. Okay, the word is used to cover all the substances and material from which the physical universe is composed. Anything you can think of, the table is a matter because it occupies space and has mass of its own. Same thing with biro, human being, anything you can think of. So with this, you now see different states of matter, which we have. We have 3 states, as the case may be. We have solid, we have liquid, and we have gaseous state. Okay, so let's start with the solid state. A solid at a given temperature, How can you know a solid? At any given temperature, it has what? Definite volume. That's the first thing. Okay, the volume don't change at that temperature except you had heat or you increase the temperature. Then they have definite shape. Okay, they are shaped. That's why they form this crystal shape. They are packed, closely packed together. They increase in size when heated. Okay, that means they increase in, don't forget, in volume when heated, when heat is being added. Okay, that's the third one. And the fourth one is that they decrease in size when cooled. There's contraction. Okay, increase in size is expansion, while decrease in size is contraction. That means they go back to their normal size when cooled. Okay, so a liquid, at a given temperature, a liquid has fixed volume. Okay, is the volume you have for water in a cup. You still meet there, except you had heat to it, or you expose it. After a while, it will change the volume. Okay, it takes up shape of any container. A liquid usually takes up the shape of the container you pour. If you pour it inside a cup, it takes up the shape of the cup. Inside the pot, it takes up the shape of the pot. And its volume is slightly affected by change in temperature. Likewise, solid. Okay, they are affected by temperature, can increase or decrease. And as well, the shape, it says the shape of the container in which is being poured, and it has what? Fixed volume. Don't forget that. And for a gas, what do you have for a gas? A gas is either a definite shape nor definite size. Has either definite shape or definite size. That means anyhow you want it, they had there. So they take up shape of any container and spread out evenly. Can you see the difference between this and this? Not that they only take up the shape of the container you pour them into, but they spread out evenly. Okay, that's another point. Okay, the third one is that the volume of gas are distinctly affected by change in temperature. Okay, you see that change is very obvious. That's the meaning. The change is obvious. You can easily see it when you add temperature to it. Okay, that's the first one. And the thing between liquid and gas is that unlike solid, they are really compressible. You can compress both liquid and gas, but gas is more compressible than liquid. Okay, so explaining the state of matter in a solid, the particles, in a solid, the particles have little freedom of movement and can only vibrate about a fixed position. That's for solid, you know, because they are closely packed together. When you had they are restricted. Okay, their movements are being restricted because they are into each other. Then this is due to attractive forces between the particles which hold them together. Okay, they are arranged in regular manner, which explain why many solid forms crystals. You know, I said that earlier on. Is the shape in which they are being packed. Then in a liquid, what do you have? The particles are still close together, but they move around in a random way and often collide with one another. Okay, the force of attraction between the particle in liquid are weaker than those in solid. Okay, unlike the solid, these one are not that close together, so the force of attraction between them are not as strong as you have it in solid. Okay, the particle in liquid have more energy on the average than particle in solid. You know, when you are free to move around, you have this energy, kinetic energy, energy in motion. Unlike solid that are just there, they are together into each other, they can't move and all that. Okay, in a gas, the particles are relatively far apart, okay? They move randomly at very high velocity, much more rapidly than those in, it's like we are ascending from solid. They are closely packed. Liquid, close packed, but not as packed as the one in solid. But here, they are not even together at all. They are relatively far apart. So they collide with each other, but less often than in a liquid. Okay, less often because they have space in between them. They are not together, so they can't bump into each other. Each person can move freely because of space in between them. And they also collide with the walls of the container. Okay, collide with the walls of container, and they collide with each other, but not often as in the liquid case. Okay, they exert virtually no force of attraction. That means the force of attraction holding them are so minute, it's so small compared to liquid or in solid. Okay, so this is a pictorial representation of what I've been saying all this while. See, solid, closely packed. They are into each other. They are so close. When you look at liquid, they are close packed, but they have space inside, in between each other. Okay, they are still have this freedom of movement. When you now look at the gas, you see in gas they are far apart. There are space in between them. That means they don't collide with each other like you have it in liquid, but they as well collide. That's elastic collision. They collide with the wall of container and with each other, but not that often. Okay, so that one takes us to kinetic theory of matter. When you talk of kinetic theory, it helps us to explain the way in which matter behaves, okay, their behavior. This theory explains the physical properties of matter in terms of the movement of its constituent particle. Constituent means what make them up, okay, their composition. Constituent particle, that's what we are going to look at. So the main point, there are three main points we are to note under kinetic theory of matter. The first one is that all matter is made up of what? Tiny moving particle invisible to the naked eyes. They are tiny. That means tiny, and they are moving. They are continuously moving, and they are invisible to the naked eyes. That means you can't see it with your eyes. Okay, the second one is that the particles move all the time. Okay, they continually move. Okay, they possess this energy in motion, which is kinetic energy. They move all the time. Okay, so the higher the temperature, the faster they move on the average. Okay, that's when you're talking of their average kinetic energy. Then the third one is that heavier particles move more slowly than lighter ones. That means the velocity, the speed at which the lighter one moves is higher than the heavy ones. So the kinetic theory can be used as scientific model to explain how the arrangement of particles relates to property of three states of matter. So changes of states, how can change occur from solid to liquid to gas? Okay, the kinetic theory model can be used to explain how a substance changes from one state to another if a solid is heated. Okay, the particle, the first thing you have to know is that the particle vibrates faster as they gain energy. Any of the three, that's solid, liquid, or gas, they vibrate, they move faster as the energy is being added into the material. Okay, this makes them push their neighboring particle further away from themselves. That's expansion. That's how expansion takes place. As they gain energy, they exert pressure, or they push each other. The neighboring particles are being pushed. That makes them expand. Okay, just like when you boil a rice, some grains of rice, you see that there is increase in the rice after boiling it. That means expansion has taken place in the solid rice. Okay, the second one is that forces of attraction weakens. It get weakens when you apply heat. Okay, whenever a solid is being heated, the forces of attraction, that's the force holding the particles together, they become weakened. Okay, when you add heat, so the heat changes the way the solid is being how can I put it right now? It's being initially modeled. Okay, it expands. That means pushes away all the neighboring and becomes swollen. Okay, so in the sense, all these forces holding them together are being weakened. With time, they are broken. And the last one is that melting points is achieved. Okay, the last one is melting point. You know, it's become melted. You can change from solid maybe to liquid. That's what it means. Okay, an unusual state of matter. You have an unusual state in the situation whereby there's a crystal called liquid crystal. They are unusual because the way they change their own states are... Okay, let me just read it to you right away. Liquid crystals are unusual states of matter. They look and flow like liquids, but some other in the arrangement of the particles, and so in some way they behave like crystals. Okay, they are liquid, but they behave like solid, kind of. You know how the solid is being packed, it's called crystals. Okay, they are now part of our everyday life. So because of this unusual state of this liquid crystal, they are widely used in display for our digital watches. We have the calculators, we have the laptop, we have in portable television. That's what they use when you have your color being changed in your TV. Okay, so they are usually in thermometer, just like we have mercury thermometer, because liquid crystal changes color as the temperature rises and falls. Okay, so there are few substances that when they are heated, they change directly from solid to gas without becoming liquid. Okay, when you heat a solid, they just change their state straight away to gas instead of going to liquid, then afterwards they go back to gas. This rapidly spread out the particle. This rapid spreading out of particle is called sublimation. Okay, that's when you say a solid sublime to gas directly. This is how it goes. It's kind of reversible reaction, solid to gas, and when you condense the gas, it goes back to solid. So this a triangle showing how the change of state can be done. Heating curve of solid to liquid. You say the solid has melted. Okay, liquid, when you cool a liquid, becomes solid, and you call it that the liquid that solidifies. That's solidification. Okay, liquid to vapor, that's boiling. Vapor cools to liquid, condensation. So you can see the solid go to liquid, go back to solid, solid directly to gas, and goes back to solid and liquid, and you see them in the triangle there. And this is how you can know the real change of states which you normally encounter in your GCE or WAEC or wherever. So you take a solid ice. You know, when you talk of solid, it has negative temperature. Solid ice of -25. When you add heat to it, the heat being added initially is just to break the attractive forces between the solid. So you might not see any increase from this. You know, they become in that phase 1, in that phase A rather, is named phase A, you have the highs. Okay, so when it gets to the point that the highs becomes water, you have it air, and it is being added. That it being added is just to change the remaining highs and liquid water to pure water, okay, to normal water. Sorry about that. So when it changes to normal water and it is being added, it is the temperature increases until when it gets to boiling points, which is 100 degrees Celsius. Okay, here when it's 100 degrees Celsius, you have liquid water boiling, and at that point any heat being added, you don't see change in the curve. It flattens the curve, meaning that all the heat being added here is just to change. That's what you call latent heat of vaporization. Any heat being added here is just to break the attractive forces of the liquid so that it can escape. So in between here, there's no increase because heat that is being added is like hidden heat. Okay, the heat is just for it to change, to break the forces of attraction between them. So as soon as the force of attraction is being broken, you see the temperature begin to rise again. That means the whole water has turned into vapor. And one thing you must note in all of this is that there won't be increase in temperature until when everything has melted. For ice, there won't be increase in temperature until all the ice has melted into water. Then that's when you have increase in the temperature. Then after boiling of the water, turning it to liquid completely, any heat being added is just for it to break the attractive forces between the liquid, and which eventually will change it to vapor states. Okay, that's the graph of temperature against time for the change from ice at -25 degrees Celsius to water and to steam eventually. Okay, I believe you enjoy the class, and for class drill you are going to do this for me. You explain what happened in heating curve of a solid ice of water to liquid and to steam. You can take your temperature of your solid ice to be anything, -2, -10 or anything. Just explain it. You might not use the graph, but just explain how the change of states is being done. Then number 2, tell me 5 things that is worthy of note about the particles of the 3 states of matter. That means you differentiate between the particle of the 3 states of matter, that's solid, liquid, and gas. So for more exercises and explanations, you can check your new school chemistry, essential chemistry, and IGCSE chemistry textbook. Okay, and stay safe, enjoy your break.